Let us look at how an ultrasonic sensor is structured and how it works. Now, it might look cute on a robot with two eyes and it is in front of the robot and all of that, but you should always remember that an ultrasonic sensor is the robot's aid to look into what the world is like, alright. It may not give it the perspective of the world, but it actually helps the robot detect what is in front of it, alright. And how this works is on the principle of sonar, sound navigation and ranging. You use sound waves to actually measure the distance between the sensor and the obstacle. Now, this ultrasonic sensor has a transmitter which is marked by T and a receiver which is marked by R. There is also a crystal here, the silver part here, and there are about 4 pins which actually is connected to the Arduino. Now, the ultrasonic sensor, when you flip around, you would see about 3 ICs, one of which is a controller and the other 2 is a comparator IC like your IR sensor. And we are not getting into the detailed functioning of how this works, what frequency it works at, but let us understand how the ultrasonic sensor actually is able to give us the distance between the sensor and the obstacle. For a simple functioning of the sensor, what happens is the transmitter transmits or emits an ultrasonic sound. When I say ultrasonic, it actually refers to a very high frequency sound signal that you cannot hear. It transmits a sound, and when it hits an obstacle, you will see that the same sound signal comes back and the receiver picks it up. The transmitter transmits the signal and the receiver picks it up. We calculate the time that it takes for sound waves to go from this point and come back to this point, which actually gives us the time taken by the sound waves to travel the distance. Now, we all know the speed of sound is about 1, 2, 3, 4 kilometers per hour, and I mean there are multiple variations of the value, but yeah, when we say air, sound travels at about 1, 2, 3, 4 kilometers per hour, and that is about 343 meter per second. Now, we know how much time it takes for the sound wave goes to hit the obstacle and then come back, and that is the time that we will use in the distance speed formula and then calculate the distance between the sensor and the obstacle, alright. We are going to write a program for this. Before that, let us just look at what pins are present on the sensor and where are we connecting. Now, we have VCC which is connected to the 5 volts. On the other extreme is the ground pin which is connected to ground or 0 volts. There are 2 pins in the center. One is the trigger. The trigger is primarily to ask the sensor to start emitting sound waves, and then the echo which gives back to Arduino the distance or the pulse which basically gives it the time taken for the wave to go hit the obstacle and come back. I will tell you again, VCC is 5 volts, ground is where we connect the 0 volts or ground, and then the trigger is we trigger from the Arduino telling start ranging or start measuring. The moment the trigger is given, we give a very small pulse like a trigger, like how we press the trigger of a rifle or a gun or a small switch. We trigger the sensor. The moment we trigger, we start measuring the time taken for the wave to come back, and then this pin here which is called the echo gives you the value in a pulse width. Now, we spoke of pulse width modulation. It gives you in terms of pulse width. We measure the width of the pulse which effectively gives us the time taken for the wave to go hit and come back, and we basically divide that by 2 because it is a 2-way distance. We need only distance one way, and then we divide by 2 and then calculate, put it in the formula, speed is equal to distance by time, and then calculate the distance, and that will give us the distance between the sensor and the obstacle. From where we left off, let us start connecting the ultrasonic sensor to our robot. I have made the connections like how it was last time for the motor driver. I1, I2, I3 and I4 connected to pin number 4, 5, 6 and 7, and I have connected 5 volts in ground to 5 volts in ground on Arduino, 6 pins that I have connected this way. Now for my ultrasonic sensor, I will need 4 pins like we discussed. So I am going to get 2 wires that have a hole on one side and pin on the other side, and then another 2 wires which have holes on all the 2 sides. Okay, I am going to use them in a way. So this wire will go from the sensor to the motor driver board, because the Arduino does not have any more of 5 volts in ground. So I am going to use the one available on the motor driver board, and this is what is going to go to trigger and echo. Now like I told you, trigger and echo were supposed to be a pulse that you are going to send, right. So what we will do here is the echo, which is basically you are reading the pulse from the sensor, it has to be connected to a pin that is capable of pulse width modulation, right, a pin that is capable of pulse width modulation. So what I do is I will go ahead and connect my trigger and echo to pin number 8 and 9. 8 gets connected to trigger and 9 gets connected to echo. So I connect this way, trigger, all right. So I am now ready to mount the sensor. So I am going to connect the ground pin and the 5 volts pin to the ground pin and 5 volts on my motor driver board. Now I am ready to mount this sensor in the front. The sensor just slides into the ultrasonic sensor holder, and we are good to go. Now I am ready to program my robot to receive the sensor signals from the ultrasonic sensor.